Hey, this is Joseph Sharp with Lead Tech Service. Today we have an iPhone Mini, an iPad Mini, Retina or iPad Mini 2 on the table. So what's going on with this guy is we have zero power um, coming in. It is taking 5 volts at 1.5 amps, so we have voltage drain into the device, but it's just not turning on. It's completely flat dead. So what we're gonna do is I have this guy plugged in right now to the wall. It's pulling about 1.5 amps. So not so great. The motherboard is pretty warm wherever that's syncing off to. And so what we can do is go through, and we know there's 5 volts going into the device. And we can see where there is 5 volts and where there isn't. So on the ZXW schematics, I can zoom in here for you. This is actually the charging port on the back of this device where this is coming in. This cable right here is soldered straight to the back of this board. And so we can see that these 5 are your 5 volt rails coming in. There's a couple others. These are all ground pins, but these are the ones that we're concerned about. So what we can do is flip over to the other side of the board and see where those go first. Just so happens to be this big guy right here. And so if we put our multimeter on that, we do not have voltage going through there. Yeah, so we have 5 volts going through there, which is, that's okay. That's working fine. We have 4.5 volts basically everywhere else where it's coming into the device. So what we can do from there, see where does this guy go. So it comes over here to this. Again, we're going to put black on ground, somewhere else, and see that, yeah, indeed, we have 4 volts here too. Now, when we get to the other side of this, it kind of splits off to there, and then these 3 are attached, and they're going to go to that. So this is where that 5 volt comes in. It goes there, and it goes there. This side is your outbound line, and that's the one I'm going to take a look at. Everything on this side seems okay. There's no voltage on a lot of this stuff because the thing is essentially brain dead. These other 3 pins, though, we should have voltage coming off of it, and especially in this capacitor down in the corner. This one is right next to the TriStar chip. So TriStar is one of those things that is going to fail more often than not. So we see that we have voltage going into TriStar, but coming out, not so much. So this guy here, we have 2 volts on. This we have 2 volts on. That's 0. That has 2. That has 3.5. Nothing there. Nothing there. One and a half, 1.8, 3/0, and 2.9. So that's all working as expected. What we're seeing is there's not voltage coming out and going across a couple of these things. So what my hypothesis is, this guy isn't quite running right. So TriStar is one of those things, it's like an oil change on your car. Just something that is a good idea and easy enough to swap out that it's not going to cause a lot of headache. So that's going to be my first troubleshooting step here, is to see why that's going out. We also know that it's pulling quite a bit to the board. I'm going to go ahead and unplug it. Switch over to diode mode. This is to test the continuity of these and find out where that leak is. If I go back in here, there is very little resistance there across that guy. If we go to this one, there's no resistance across that, so potentially could be that. This one has no resistance across it, so it could potentially be that as well. What these all have in common is the TriStar chip. If I flip back over to ZXW, what we can see is what these guys have in common is, of course, ground. But then on the top here, well, that's going to TriStar. That's part of TriStar. That's part of TriStar. And those are guys that are apparently grounded out. So we need to find out, you know, hey, maybe this chip is bad and it's failed in a way that it's basically grounding everything out to it. So what I'm going to do is go ahead and swap this guy out. Again, it doesn't take a whole lot, but that's going to be my first troubleshooting step, and we'll see if those the grounding situation is taken care of. Basically, we have too much voltage going somewhere it's not. It's like if you blew a pipe in your house and you're getting a big water bill. There's water going in, but it's not going in the right places. So I'll put on some tunes and swap this guy out, and feel free to ask any questions in the comments, and I'll be happy to respond. So my hot air gun is set to 350. I have a dab of flux on here. It's been a minute. I had to reset OBS, so I'm gonna add a little more flux. Get it nice and goopy for you. I'll come in here, and we're just gonna float this guy out of the way. I am right next to the battery, so I'm gonna do this as quick as possible. Get it in and out, and try not to nuke us all. Okay, so that guy's out of the way. That's our old one. I'm just gonna set it aside. While this board's still hot, go ahead and clean up all these pads. Believe it or not, I need more flux. So what flux does is it prevents oxygen from hitting the molten metal. It gives everything a nice clean finish. If you find that your solder wants to stick to other things and it's really stringy, or you're getting little peaks and caps on things, what you want to do is add a little flux. And then go in there, see how nice it cleans that up. So that's how you get those nice dome-shaped solder joints and nothing with big spires coming up the top of it. Okay. So those are all cleaned up. Those look good. Gonna clean that a bit. And so we have successfully resolved the short. This capacitor here was shorted out a moment ago. It no longer beeps in diode mode. This one may. Let's see. Okay. And those are no longer shorted out either. So I believe we successfully resolved that short. We'll put the new TriStar on it. Let's see if that actually holds true. This TriStar is from Mobile Centrics. They send it in a kind of fun bag. They have decent prices on these. I would prefer to order by the reel, but when you have low volume, it's kind of few and far to come to order these. Unless you want to order, 100 of them, probably not worth it. I go through 10 a week, so not terribly worth it yet. What I'll do is take it out of this casing. This is part of a reel. These usually come on a reel of about 1,000. And so what we'll do is remove this from its little house. And put some more flux where it's going to go. Just need a little bit. Enough to cover over where you're putting it down. And then we're going to set it back. That looks okay. This is a A2 on the schematic for the iPad Mini 2. They're recommending the 1610A1 TriStar chip. The A2 and A3 and A3B for that matter are actually the same chip. Same layout and everything. They're just a little bit upgraded. The 1608 that came on the iPad Mini 1 is actually different. It has a different pinout and it's a little bit bigger than this one. So that is not something you would want to use to get this guy going again. You could potentially damage other things on the device. It's just bad news bears all over. So I kind of put this guy in place. Again, we're going to flip over to ZXW. And so on here we can see that A1 is this non-connect chip up in the top left corner. This is A1, A6, F1 is in this bottom corner, and F6 is here. So this A1, I'll take out non-connect. This A1 chip in the top left, that is where we want our dot, and so I do have it there. The dot is in this corner, and so that signifies A1 no matter where you're at. And then if you don't have schematics, just take note of direction before you take these things off, because it can be kind of troublesome putting them back where they go. So I'm just going to set this guy where it goes, and it's a bunch of marbles sitting, the top half of marbles sitting on the bottom half of marbles, so it doesn't want to sit where it's at so well. So what we'll do is just kind of put it there. I'm going to turn down my air pressure to about 30. That's going to keep this chip from basically blowing away on me. If you've done that before, it is the most frustrating thing. So I'm just going to heat it up slow. This is a new chip, so it has a little bit higher melting point than remanufactured, and that's what I was talking about. So I was able to catch that one, and now that it's more or less stuck in place, we can really lay some heat to it until it is melted, and we can kind of poke it, and it should kind of jiggle back into where it wants to be. There we go. Now if we poke it, it bounces back. It's happy now. That's where it wants to be. I'm going to set that back. We'll let it cool off for a moment. I would advise not putting alcohol on something that's boiling hot. It usually doesn't turn out well. The alcohol won't burst into flames or anything, but it does tend to leave a residue when it boils off like that. And so there's no more ground on this side. So it sounds like we've resolved this short. This capacitor was shorted out. It beeped on both sides. It's only supposed to beep on one, so now you can see there's a beep, no beep, beep, no beep. And down here as well, that's supposed to beep, and that one is not supposed to. And it is. That one could still be bad. And those may still be bad. I thought it looked alright. Let's see. So there is still a short on that side there. So I can hazard to take this chip off again. I probably will do that. The 1610As are fairly cheap. I didn't check anything underneath it, which I should have. So we're going to go back and do that and do it properly. Thought this was going to be a quick repair, so I'm going to put something over this battery because that guy's starting to make me nervous. So I'm going to crank my temperature back to 350, air pressure back to 50%, and I'm going to remove this guy once more, now with a nice shield over the battery so we don't explode all ourselves. Okay. That's that. I'm going to flip it over. It doesn't look like any of those were shorted out. It could have been from where I moved it. It could have shorted something out. Gonna test this again. Figure out what's going on here. Okay, so we do still have a ground situation there. So TriStar was part of the problem, but it doesn't seem to be the entire issue. So let's take a look. Back in my schematics, what we can see here, these are the guys who are shorted out. F4 and F5. Sorry, F4 specifically is the one that's shorted. So that is the bottom row, third from the left, third from the right. So that one definitely does beep. 1360 is a likely candidate that can go out. We also have a power module IC here. And there is a pretty big cap right here. All of these are going to be grounded out. There are only 2 capacitors on this line. That could be bad. So what we can do is remove, well, 4. We can remove these that are potential candidates. We can go up here and test this one too, just to prove, and see that one is also completely shorted out. That guy is shorted out. Let's see if they're related. They're just neighbors. We zoom out. Those two are nearly side by side. One thing we could do is remove that power module IC. This big sucker here with all this stuff around it. That's an option. I'm not super privy to that one though. That just doesn't sound fun to me. Maybe something I have to do, but if I can avoid it at all costs, you know I will. So let's flip back over to the other side. Maybe there's something over here. And nothing, just a test point. Lone test point there. TP93B0. And nothing really else to see. So these boards are fun to work on because you only have one side that you're testing. The other side has test points on it, but most of it you can do through the schematic or through that. So I'm going to start removing capacitors. We'll see if that isn't a valid solution to this problem. I do want to kind of heat shield this battery some more. I don't enjoy soldering next to batteries particularly, but not removing that certainly does make things faster. What I'll probably do as well is remove some of the shielding around the corner. That'll make my job easier to go in and remove and to replace some of these caps. So give me just a second and we'll do that. If we can't damage this board, or if we can avoid damaging this board. So there's an opening kind of there. This is soldered, that's open. I'd like to come in here, kind of put a notch in this. So this is like creasing a piece of paper. I don't want to remove this entire side, but I do want to break this off. I'll flip it around there for A little bit easier access. So the way to cut through this guy is actually using the back of my X-Acto knife, and it's making little shavings as it's going by. I probably wouldn't recommend this if you're using a medical scalpel, but a good old X-Acto knife usually does this pretty well. Tend to abuse these things pretty bad, but I go through a blade about once a week. So now that that is removed, we have pliers and tin snips and other things that we can go in and try to remove this guy further. When you are doing something like this, just be aware that there are capacitors and diodes all around right underneath this metal. So if you go prying and pulling, you can pull these little guys up. The other thing is when you are shaving the stuff away, there will be metal flakes produced. It's one of the factors that led me to turn this board around. I want these metal flakes going outside of the shielding and not under the shielding. Typically underneath the shielding is where you're going to have the more sensitive components. Outside the shielding, kind of anything goes. Apple's aware that we're going to have dust and stuff in these devices, and so it can kind of float around in there without hurting too much. When I'm done, I usually use some Candy or something to kind of dislodge that. So very carefully trying to peel this guy back here. And so here as well. Okay, let's see if we've made any progress. I'm gonna get this guy back out of the way. I can potentially reuse that chip. This one is fine. The first one I took off was in fact bad. It wasn't the root issue, it was a issue, but it wasn't the cause of our problem here. So, put a notch in that guy. I'm using my nice tweezer to do this, so we're probably going to stop doing that. So that's good. So that guy's good. Battery has little indentation in it, nothing catastrophic, fortunately. What I am going to do is try to shield that the best I can without removing it fully. If I go to remove that battery or remove this board from the device, cellular, it'll probably take me 30 minutes or so to remove the board. It'll take me 30 more to put the board back in it. When we're troubleshooting like this, it helps not to do things like that, just to get the device in and out a bit quicker. But you do have to be aware that, you know, if you do want to do this and you want to do it right, it's in your best ability to remove stuff like that. So now that I have those removed, I'm going to put some tunes back on, because it's awfully quiet. All right. What we're going to do is remove these one at a time and check to see if we've actually resolved the short. One thing Jessa likes to do is to just wipe boards clean of any and all components that could be the fault. I tend not to do that because I like to track down the real issue, kind of triangulate issues and figure out, you know, hey, where's this coming from? In this case, we have two reasons that it could be bad. It could be this capacitor up here in the top left of the screen, or it could be any of these three right here in the middle of the screen, or there's also a capacitor up here. That could be the issue. So we need to remove these one at a time, check for faults, and see, you know, who's to blame. That's my new game. I'm gonna flip my light around here. Okay. You may be able to get a better look at these capacitors. The ones in question are sorry about that. The ones in question we're looking at are these two here in the bottom. This one, all three of those are on this chip here in the bottom row, third from the right. And then the other one in question is this guy. However, this one is also shorted out. One thing you can check is the schematic. So when we look on here, C8232 is an issue. Okay. No matches were found for that. And C8240. (8232). There we are. So these are LDO bypass rails. These are coming off of the main power supply. We see LDO outputs and LDO inputs. So we have an issue with one of these outputs from here. So 40 here. That's another one. The issue is that we have audio outputs. The audio inputs are good. We have power on VCC main. We have 1 V8 is online, 1 V2 is online. Everything else seems normal. It's just those two seem to have some kind of ground fault issue. So whether that's the case, but usually when you hear something heating up, what's happening is something's gonna awry. Either inside a chip or a capacitor has basically failed, and it's failed open, where it's supposed to be kind of a gate where it fills the lock and then it empties the lock, and then it does it over and over again. But what happens as they get old is they just empty. The gate doesn't open and close anymore. It just stays all the way open. And so that's not particularly good for something that's supposed to filter out signals. We don't want these things to have continuity to ground, because what we can do is just pump gas into it, and there's just a leak. So I turned my hot air gun down to about 280. That's a good place for working with these capacitors that we don't want everything else just blowing off the board. I could add some low melt to this. May need to. I'm not raising the temperature anymore. I'm just gonna come in here with some flux. Piece of plastic on this board that is not happy with the heat I am providing. So I'm going to remove this guy. Molten plastic on the boards is typically frowned upon. especially if you have a shrinky-dink thing like on our video connectors here. If I applied heat to this, or to the back of the board where this was molten, by the time this started to shrink, these would already be molten. And when this contracted, it'll actually pull these off the board. And again, that's not something that's terribly fun. It's not something I want to do today. Okay. A bit too much solder there. Gonna wick some of it away. Try not to use solder wick a lot. On components this small, it tends to pull pads off the board. This stuff is a little too fragile to use wick with, but what you can do is you take a clean soldering iron, and this soldering iron wants to be tinned at the end of the day. That's what it really wants. So if you take a clean soldering iron, it'll actually pull solder from a glob like that. Not terribly fast, but it gets the job done. It is a heck of a lot cleaner. There we go. And not that it really matters. But I like for that to look clean. So we're gonna do, come back in here with heat. And we're gonna kind of try to nuke this guy. Okay. There's one solder off, or one capacitor off. Again, we're going to check F4 there. Okay, so that's ground. That's no longer grounded. That's grounded. That's no longer grounded. So this is the solder joint we're concerned about. So we no longer have a ground fault there. By removing that capacitor, we can say almost without a doubt that's what was causing that to draw that power and potentially failed that TriStar. There's no more short there. Coincidentally, there's no more short there, so removing this big chip could have helped us find our issue, but it's a whole lot harder to remove something like that than it is to remove one tiny capacitor. The reason I knew to remove this one as opposed to these two or this one over here is this form factor of capacitor is what most iPhones use inside different circuitry. It's what we call a common cap. It's one of the ones that is just everywhere and will fail every time. So on the iPhone 6 Plus, where you might not have any video, that could be the issue. On an iPhone 6 where there's no backlight, that's probably the issue. Where you have something that's searching no service, or there's a spot that gets really hot. Even on newer and modern boards, it's usually that size capacitor that's going to fail outright. And so now everything else here appears to be corrected. Let's run through real quick and see if there's any grounded spots that aren't supposed to be grounded. And those are... that one is ground. And that one is also ground. So if we look back at our schematic, this is $1610. The pins here, F5, C1, A6 are what should be grounded out. On our schematic, these are our grounding pads of 1610 A1, and then E6 can also be grounded out if this is bypassed. So on here, C1, D2, A6, and D2 is right there. The schematic is most likely wrong, unless that UART is always supposed to be grounded. So F5, A6 are definitely grounded out. And then C1 is actually grounded out. I missed that the first go through. And then D2 is not actually a ground. So I'm okay with that. There are different reasons why something can be grounded at one point, not another. It's basically like a switch that's going on and off there. So I'm going to continue to clean this guy up. Probably will replace that capacitor, just because they are common caps. They tend to be everywhere. Those are good. The C1360 is what I actually removed. We search the schematic for C1360. We have a 1 microfarad 10 volt 0201 capacitor with a 20% on it. So there are other ones in this row. Do that, probably not terribly necessary. To replace that guy, but just for laughs, let's see if we can find another one. Okay. So we're going to open a another PDF here. Probably a iPhone 6 or 6 Plus. That's what I have the most boards for. And see if there are something like that we can steal parts off of. Search for 1 microfarad. And that's a 6.3 volt. It's a 6.3 volt. 6.3. And we're looking for something that is, in fact, 10 volts. 1 microfarad, 6.3. Ooh. That one is 16. This microfarad reading has to be the same, but you can actually go up with voltage because it's a higher rating, and it is also an 0201 package. So let's see where C2440 is located. And that is right above the audio IC. Okay, so we have iPhone 6 Plus boards here. I have a whole slew of them. I call locked or just simply damaged that we can steal parts from. I'm going to set this right in front of this device. Typically I set it on, whoa, this is not a pretty board. Let's use another one. Oh, that one looks better. Let's see. Yeah, that one looks okay. What we're looking at is we have a big one, and a small one. So on here it's a big one, and a small one. The orientation is different. Usually what it's looking at is something like this. This is just turned 90 degrees. So it's this guy right here that I'm going after. The easiest way to do that again, we're going to add a bit of flux there. It's too much solder. Alright. So crank the heat back up to 350. I'll run in and kill this guy real quick and apparently move everything else on site. Put that back aside. It's getting moved straight onto this board. Gonna kind of chill right there for a moment. molten. Just stick that in place. I'm just going to clean it up. So IPC regulation says that this can be 50% to the pad. So this can be one side or another of this pad by half the component width. So that actually was in spec. It would have been fine. But if you just give it a little poke, it wants to set actually pretty normal on there. It'll self-center itself. See if I nuke this component getting it off. That's grounded. Ground, and that's not. So now, instead of this component having a 10 volt limit, it now has a 16 volt limit on that circuit, which shouldn't hurt anything because it's still only running at 1 microfarad. I could go ahead and clean this guy up. Actually, will. There's quite a bit of debris floating around now. Try to clean this up as best as possible. You have junk floating around on this board, you don't know what it's going to fail out next. It could land between two critical components and just make the thing stop working again, or else something worse like it fire or something like that, God forbid. The way these components are, or way these devices are manufactured is if you have a short, there's other things that are going to fail out to stop that leak. So in this case, we had a failed capacitor. Those happen just because of age. It's time is what usually causes those to go out. And they'll fail. So that's done. And because that failed, it tripped this out, and we were getting a short on this one too. So we could have removed both of these, tested that, and then this, and tested that. But kind of as a rule of thumb, if you're having power issues with any Apple device, and you have something more or less of what you're looking for coming from TriStar, go ahead and yank TriStar off. It's one of those components that you want to test as much as possible beforehand. I do have a handy dandy TriStar test board around here somewhere. I've used it once with some success, but typically this is my troubleshooting process for something that has no power on it. So worry about refurbishing that TriStar later. I'll pull another 1610 A3 out. I'm gonna swap this out. And again, I'm gonna check the board view layout, and we can see A1 is in the top left corner. So we're gonna keep that component in the top left. Just gonna go ahead and set that in place. Add some flux. Okay. just gonna realign that. Okay. So just gonna place that in its spot. It's the same as the first one we did, where it doesn't like to sit there because it's like stacking billiard balls or something like that, where they just don't like to be where you put them. Just gonna lightly hold this in place. Add some heat. That one is totally botched. Set that one aside. Clean this up again. Is it the black? Yeah, that one. Okay, so we have swapped out that IC, apparently 3rd time's the charm, to get that guy replaced. But it is where it needs to be now. I'll have to go back through and replace or reball those other two that I destroyed on installation, and get those working again. So that's looking okay. I'm probably going to grab their digitizer in it and screen and just try those out. I did shield off that battery for the second half of the repair because I was doing a little more in-depth work than just removing something. But what we have now is this no longer indicates a path to ground. This one doesn't either. The capacitor up here that I was looking at, that was also shorted out because it's on that line, is no longer showing grounded. And this one that was shorted out as well is no longer grounded. So, let's cross your fingers. This one should boot up. Let's say it's a successful repair. The shielding here is going to be covered up by the actual top plate. And then there's another plate that goes over that. And then the capacitor that we replaced is actually a little bit stronger than the one we took off. So that should prevent that from happening again. Even if there's too much draw downstream, it shouldn't blow anything else out. The 1610 we installed is actually the upgraded one. This is a 1610A2. The 1610A3 would have worked as well. The one we removed was actually a 1610A. So those all look good. Battery's still unplugged. If we plug in the multimeter, plug in the battery, plug in the multimeter, see. Still has a pretty high draw on there. So, with that, I'll unplug the battery again. And Okay, and so we're getting a low battery signal on the sky. So that's new. It wasn't doing that before. We had absolutely nothing out of this device before. Plug this in again. So it shows it's charging now. That is a very good sign. I'll wait for this guy to charge a little bit, and then reassemble it, and it should be good to go. So that concludes the stream. In the future, I'll be taking a look at some other stuff. I have a couple cool projects on my table, a few Apple Watches, a couple larger devices to track down the issue on those, and to repair a couple medical devices. But for this stream, that concludes June 7th, 2018. Have a great day.